All you need is solder, soldering iron, and something to solder. So like a piece of wire. The first thing we're gonna learn is through-hole soldering. So I'm gonna flip on my soldering iron. I like to keep my soldering iron at 650 degrees Fahrenheit because I'm American. Definitely don't touch the tip, but if you do, immediately run your finger under cold water and apply whatever weird herbal medicine your mom believes in. A really common mistake that people make is when the solder isn't working or when things aren't going right, they jack up the heat on the soldering iron. That's the last thing you want to do. You want to turn the heat down. You really don't want to run it too high or you'll start burning things off of your board. Perfect, my soldering iron just heated up. So the first thing I want to do when I get this is tin the tip of the iron. I'm going to do that by just pushing it against the solder, and you'll notice it kind of disappears. You've now got that glob of solder, and I'm just going to throw that in our steel wool. But that gives you a nice, clean, non-oxidized tip for soldering. Solder flows to where it's hottest. So wherever on your part is the hottest is where your solder is going to be, which means that if you're only putting heat on the pin or on the solder or on the board, that's the only place the solder is going to go. And then the other thing is that heat flows through surface area. So the more surface area you have against an object, then the more heat is going to go into that object. So the key is that you want to get an equal amount of surface area between the soldering iron tip, the pin, and the little copper circle around the board. So to do that, I'm just going to wrap around. I'm going to tap the soldering iron on both and make sure, so I've got a pretty even amount, and then add solder in. And once there, and there you've got a nice joint. And you want to get that nice little pyramid. And so I'll show you again. This angle is really difficult to solder from. And always be sure to be cleaning your tip frequently. It's kind of like painting, you know, you want to make sure that your brush is always clean and has enough pigment on it. Keep in mind it's okay to start by putting your iron on the thing and letting it heat up a bit before you go in and add your solder, because then it'll flow much more nicely. Now I'm ready to go, and I can lift my beautiful thing off, and you'll see you've got these header pins. They're nice and straight. So another thing we're going to learn is how to desolder. So say you soldered something on and then you screwed it up and now you have to take it off. So my number one way to desolder is I like solder wick. This is just a braid of really thin copper, and you can pull it apart here so that you can see. Think of it like a sponge for solder. You know, it's got a bunch of holes in it and the solder can flow up the wick. Now maybe I'm feeling like this connection shouldn't have been made. So I'm just going to hold that on there and really press the soldering iron into it. And if the solder wick is filling up, so you can see that's got a ton of solder in it. So I'm just going to move farther up the wick. Don't be afraid to really get in there with your soldering iron. And now we've got a slightly more silver eye, except you've removed your mistake. Good job.
Okay, so let's start with the very basics. Soldering is when you fuse together two electrical components using a metal alloy called solder. And by the way, yes, I'm aware that most other countries pronounce the L in the word solder. For whatever reason we decided not to in the United States, wasn't my idea. Anyway, that alloy comes in several formulas that are made up of metals like tin or copper or lead. Personally, what I like using is 60-40 rosin core solder. That means that it's 60% tin and 40% lead. You can get it without lead, but I find that a little bit more difficult to work with. So if you're using one that has lead in it, just make sure that you wash your hands after you're done. It also comes in different diameters. You can get really thick or really thin solder. Personally, I prefer thinner because it makes it easier to fit inside pinholes, and it also makes it easier to control how much you're applying. Rosin core means that the center of the solder is made up of rosin flux. Flux is another important component of soldering. It's used for cleaning metal surfaces and removing oxidation and just getting them ready to accept solder and fuse with it. There are a few different types of this as well. Some of them are very thin and basically evaporate as you work with them, and some are thicker, although those thicker ones can leave a sticky residue that is sometimes corrosive, so you'll want to clean that off with some alcohol when you're done. If you're using rosin core solder, then in most situations, you won't have to worry about using additional flux, although you'll still want to clean off that residue that the rosin leaves behind. Flux can be especially useful for working with ribbon cables or tiny pads on a PCB because it'll facilitate better surface tension to sort of pull it onto the metal pads where you want it to go. Now, a couple of common mistakes that I see people making when they're first starting out. The first is that I'm trying to figure out what these people are thinking. I think that the issue is a lot of people seem to think that the goal with soldering is to sort of melt the solder onto whatever you're trying to join together. Almost like you're squeezing icing onto a cake or something like that. That's not the case. Instead, what you're trying to do is heat up both of the things that you're trying to fuse together and then melt the solder into that. Might seem like a small distinction, but it is incredibly important. Because if you do it the other way, if you just kind of dribble the solder onto whatever you're working on, first of all, it's going to be really messy. But you'll also run into what's called a cold solder joint. That's where it might look like the two things are connected, but it hasn't actually fused with one or both of those surfaces. So you'll have an intermittent connection at best, or at worst, no connection at all. The other issue that I see constantly, the old saying, less is more, that definitely applies to soldering. You only really want to use just enough solder to make the connection. Sometimes you'll have a good reason to use a little bit more. For instance, on the Minty Pi where the L and R button board connects to the power board, you should make those solder joints a little bit bigger because they're actually kind of physically reinforcing that connection between the two boards. But the vast majority of the time you only want to use just enough to make that connection. If you use too much solder, then you run the risk of bridging whatever you're connecting with some neighboring components. That can be really bad, to say the least. So I'll start with probably the easiest type of component to work with, which is through-hole components. You can find all kinds of different components in this form, like capacitors and resistors and LEDs, and they've got these long legs that are meant to go all the way through a circuit board. You find these a lot in commercially made boards, like these giant capacitors on this printer controller board. For some of them, you might have to bend the legs to make them fit into the board, and I'm just using it with some prototyping board here just to give an example. Slide it into the pinholes and then bend the legs outward to hold it into place. Use the tip of your soldering iron to heat up both the pinhole and the leg at the same time, and then feed a little bit of solder onto it. A good temperature to start at with soldering, by the way, is between 300 and 325 degrees Celsius. And that's it. Like I say, really easy to work with, and you can see that I hardly had to use any solder at all. That's kind of a theme that you'll be seeing here, is only use as much solder as you actually need. So next up, let's talk about wire. This is the kind of wire that I like to use. It's coated in silicone, so it's nice and flexible, and it's not going to melt from your soldering iron either. It's also really easy to strip. You can do it with your fingernail, and this is stranded core wire, meaning that it's made up of a bunch of tiny individual strands of metal. You can also get solid core wire, which, as the name implies, is made up of one giant thick piece of copper in the middle of the wire. I've only needed to use this a couple of times. It's much more difficult to work with. 99% of the time you're going to be using stranded core wire. So the first thing that I want to show you is tinning wires, which is the process of adding a little bit of solder to it to make it much easier to connect to other components. To do this, strip a couple of millimeters of the wire, and then twist all of those strands together nice and tight. Then you're going to heat them up and apply just a little bit of solder just to coat them and hold them all together. And that's it. This is something that you'll find yourself doing quite a bit, so it's a good thing to practice. Sometimes you need to connect wires to pinholes, like for example if you're connecting a battery to this charging board. To do that, first prep the pinhole by heating it up from one side with a soldering iron tip, and feed a little bit of solder down into there. Then you're going to want to twist and tin the wire like I just showed you, then heat up the pinhole and slide the wire in from the other side. Now in this example here, I actually didn't feed quite enough solder down into there, so I went back and added a little bit to the back. This is about what it should look like when it's done. As you can see, the hole is completely filled, but it doesn't stick out very much at all. It's nice and smooth. Also, notice that I don't really have any wire exposed on the top of the board here. I inserted the wires all the way into the pinholes so that there's no metal exposed and you can't accidentally short something out. Sometimes you need to attach wire to a board that doesn't have pinholes, so you'll be attaching them directly to pads on the board, like with this Retro PSU board from Helder. Really nice battery charging and boost port. So anyway, I'm going to be attaching a couple of wires to these battery pads here to add a JST connector to make it really easy to connect and disconnect a battery. So first, again, strip a couple of millimeters of the wire, twist it, and tin it, just like you've seen me do now in a couple of examples. Should look about like this when you're done. Some types of wire like this you need to be a little bit more careful with because they do melt, unlike that silicone coated wire that I was using before. Then heat up the pads that you need to attach the wires to, and feed some solder onto the board right at the tip of the soldering iron. This is about what it should look like when you're done, just a couple of nice smooth bumps that stick up maybe a millimeter or so. Then you can heat up those blobs of solder and just kind of insert the wire into them. Having them tinned beforehand makes it so that they should just kind of get absorbed into that blob of solder pretty easily. Notice that I only stripped as much wire as I needed. Beyond just keeping it nice and clean looking, that's really important so that you make sure that you don't accidentally short something out somewhere. I'd also recommend a couple of things for taking care of the tip of your soldering iron. First, a wire type tip cleaner like this one. As you're working on a project, you'll accumulate some buildup on the tip. One of these makes it so you can clean it off periodically while you're working on something. The other thing that I recommend is a tip tinner and cleaner like this one right here. Basically, when you're done working on a project, you can stick the tip in there while it's still hot, and then clean it off and your tip will look brand new when you put it away. These tips do wear out over time, but taking care of it like this will make it last a lot longer. And then the other thing that I'd recommend is a silicone pad to do all your soldering on. Basically nothing sticks to them, including solder. It's not going to melt it if it drips on it, and you can get them with these built-in trays to hold screws and things like that while you're working on projects.